Okay, so in the last example, we looked at a couple of point charges along a line, Q sub A and Q sub B. Q sub A had a charge of -3 nanocoulombs. Q sub B had a charge of +2 nanocoulombs. And we know that those charges are separated by a distance of 13 centimeters. Q sub A is 5 centimeters from the x-axis. Q sub B is 8 centimeters from the x-axis. And so in the last time we looked at what is the potential energy due to the charges, and then what is the electric potential at a point above the x-axis. The last question to answer is there are some points along the x-axis, maybe, where the potential is 0. And I want to see if we can solve for where those points are. So the condition that has to be met is that the sum of the potentials V sub A plus V sub B has to be equal to 0. So it must be true, let me write that just a little differently just to clarify, it's equal to the potential, and the potential at any point then is equal to 0. So it must be true here that the constant K times Q sub A divided by the distance R sub A plus the constant K times Q sub B divided by the distance R sub B is equal to 0. Now, let me try and clarify this here. If we look at the distance from any point, let's say along the x-axis, I'll just call it x, to Q sub A and to Q sub B, the distance to that point is going to be, well, first of all, I'll factor out this constant K here, Q sub A, and the distance would be x minus the position of x sub A. And it's also worth noting here that this is always a radial distance, so this distance here is always positive. We would never make this negative, so we need an absolute value sign. And then similarly, x minus x sub B is equal to 0. So it's pretty clear that this quantity here, Q sub A divided by x minus x sub A plus Q sub B divided by x minus x sub B is equal to 0. Now, let's Q sub A divided by x minus x sub A equals negative Q sub B divided by the absolute value of x minus x sub B. Let's put in some numbers here and see now if we can solve this for the points, and there will be more than one because of the absolute value sign of x. And we'll just remember here that Q sub A is -3, Q sub B is +2, A is 5, and B is 8. So Q sub A is -3. Now, these are nanocoulombs, but I don't really need to worry about that because I have nanocoulombs on both sides of the equation, and so it will cancel out. Similarly, I don't really need to worry about, I'm going to leave the numbers here in centimeters for the same reason, because I have centimeters common to both sides of the equation, so whatever units I choose to use here will cancel out on both sides of the equation. So I have Q sub B is +2, but there's a negative sign in the equation, so negative +2. And this is the absolute value of x minus 8.0. Oh, now wait a minute. I've got to be careful here. X sub A is negative, so this is negative. I made a mistake here. This is negative 5. See, because x sub b is negative 5 centimeters, and so if I subtract negative 5, I'm actually adding. So let's clean this up a little bit. I've got I got negatives on both sides of the equation, so the equation here actually looks like 3 divided by the absolute value of x plus 5, and that's equal to 2 divided by the absolute value of x minus 8. So we're ready here now to just cross multiply and solve. So if I cross multiply, I have 3 times the absolute value of x minus 8 equals 2 times the absolute value of x plus 5. There are therefore 2 equations that I can solve because of the absolute value sign here. So let's solve the case for both of them. It has to be true that 3x, I'll multiply the left side out, minus 24 is equal to, now let's take the case first where this side is positive. So this becomes 2x plus 10. So this is easy enough to solve. I had x is equal to 34. It looks like is the solution for one side of the equation. Now the other solution would be where the other side is negative. So this is 3x minus 24 is equal to, and I'm going to make this side negative. This is negative 2x plus 10, which is negative 2x minus 10. So now if I solve, I'll have here on one side 5x, and let's see, on the other side we'll have 14, right? So the other solution here is x equals 14 divided by 5, which is 2.8. So my two solutions, x equals 2.8 centimeters, that to me makes sense because that's a point somewhere in between the charges. But that also says that there's a point way over here to the right of q sub b where the potential is also 0. And, well, that's it.